All right. Well, thank you for coming to class today, and I think this is going to help just to spend some time just working problems for 4-7.
Yeah.
4-7 was very confusing if you don't work problems, but you know, you just get lectured at.
4.7.
So we're going to work the problems. So if you want to print that out, it's in Shelby. I posted it last night at 10 o'clock. Okay. Actually, all right, guys. All right. So here we are.
Oh, good gracious.
Well, we're going to do this worksheet here, and I'm going to be referring to the book a little bit later. So we've got the angle whose sine is -1/2. That's what this means. And we write it up here. The angle whose sine is -1/2. That's what this means. This is a number inside the inverse sine. This is a number. It's not an angle. So you got to get it right between numbers and angles. So your first step is to write theta, that's an angle, equals inverse sine of -1/2. And, or you might just write theta equals over here to save writing all that. Okay, because that's an angle. We're looking for an angle. And I did tell you it's measured in pi radians. Okay? And then you write, this is not equals, this means that the sine of theta equals -1/2. But we do need to remember that sine has a restricted domain of -pi/2, and I'm just going to write it like I'm just going to write it like this: inequality to pi/2. In order to make it 1-to-1, we're only using the part of sine. And I can draw a picture. Sine usually goes. No, we can't use that part. We're only using this part of sine to make it 1-to-1 horizontal line test, not this part. Okay, that's why. So we're restricting the domain on sine so that we can have an inverse function. So we have to pick theta, so it's between -pi/2 and pi/2. So we look at our unit circle between -pi/2 and pi/2, and you do need to know that this is -pi/2, and this is pi/2, and sine is -1/2. That's sine is, you need to know that's your y-coordinate. So look where the y-coordinate on your unit circle is -1/2, right there. So this angle here is -pi/6. So the answer is -pi/6. Any questions? Does that make sense? A little bit? A little better? Okay. So we looked on the unit circle. where between these angles where the y was minus 1/2, and then we read the angle, but it had to be between these angles, so we couldn't use 11 pi over 6. We had to use negative pi over 6. So theta equals negative pi over 6, and that's our answer. The inverse sine of negative 1/2 equals negative pi over 6. And I probably should have left more room if I'm going to write all this stuff. But
so what's the point of the inverse? Why is it even there? Like, you know what I mean?
it means the angle to sine is negative 1/2 because this is just a number, and we're looking for an angle. Why doesn't it just say sine of negative 1/2? Because sine of negative 1/2 is not negative pi over 6. You want to put sine, you want to type in your calculator what? Like a switch. Sine of negative 1 divided by 2 it's, why do we have the inverse sign here? Now I can do second inverse sine of negative 1 divided by 2, which is 0.5. And my calculator is in degrees right now. So we need, the mode has to be in radians. And this is the decimal approximation, second, that's negative 30 degrees. Or maybe you want it in degrees and convert to radians, but that's, your calculator did it. So you're getting confused between numbers and angles, I think. Okay? Why do we have inverse sine? Because we're looking for an angle. This is a number, we're looking for an angle. Theta. We just call it theta to show that it's an angle. And so what this means that sine theta is minus 1/2. And theta is the angle we're looking for. But sine has a restricted domain between here. So then you look on your unit circle where the y coordinate is negative 1/2 between here and here. And then you have to be able to read the angle off. We had to convert it from 11 pi over 6 to negative pi over 6, okay? So you do have to be good at radians here. We're doing everything in radians in this section. If you struggle with radians, you mess up. It's not 11 pi over 6. We're going to take 2 pi, or 11 pi over 6 minus 2 pi and get this angle. We could, or, you know, because what do we have left to get to 2 pi from 11 pi over 6? 1 pi over 6. And it has to be, we're going from minus pi over 2 to pi over 2 with the sine function. Okay? All right, see if you can do the next one. So you have to rewrite it. You can just write, this is a number in here. You can just write theta equals over here to save room. And then you're going to be writing something like this next. And then you're going to look at the restricted domain of the tangent function. Did I figure it out? And you can't just put answers.
No.
Oh, okay. Are you working it out? Oh, well, you got to write these steps. You don't. If you just write theta equals this, you don't just write this step. But you should write this step. You should write what the restricted domain is to help you, and then you look at the unit circle. If you don't write work down, you're gonna make mistakes probably, and you won't understand it. So, there's just a couple steps to write down. What'd you get? Yeah, okay. Do you look at your unit circle? You don't have unit circle? Okay, it should be pi over 4. Yeah. Okay, well, we put sine over 1 over Okay.
I'm confused on where to go next.
What do you got so far?
I think I need to get a sign of this.
Yes, you have to look at your unit circle, and do you have one with you?
Yeah.
Okay. Get your unit circles out, guys. You gotta look for tangent. I'll write it on the unit circle. Tangent theta is sine theta over cosine theta. So on the unit circle, that's y divided by x. So you have to find you have to find where tangent theta equals the square root of 3 over 3. And it has to be in the restricted domain of the tangent function. So,
Tangent is the same, right? The restriction would be the same, would be from
minus pi over 2 to pi, to positive pi over 2, but not including those endpoints, because those are asymptotes. So yes, it's pretty much the same. Restrictions are pretty much the same for tangents, except it doesn't include the endpoints. That's a very classic. Did you get this?
I'm just printing out the file I did it last night.
Oh, you did it? You did it, right?
I believe so. You can check it if you want, but I believe that it's right.
Well, there was a reason, right? Because you're not in the restricted domain of cosine between 0 and pi. So you got to memorize these restricted domains. Cosine goes to 0 to pi. So you have to pick the x between 0 and pi in this section. Good. Well, that's good that you've already looked at it. Wow. Okay. All right. Did you get these?
Yeah.
You got pi over
She
2.
tried to explain this to me. I think I did, but so like you just figure out.
Well, you're right. Theta equals this. Then you write, which I had originally had the wrong numbers. This will do no such thing either. It was late on me. Theta equals that. When you write tangent theta equals that. And then the restrictions on the domain for your tangent function is this. And then you look on the unit circle between minus pi over 2 and pi over 2. And you actually, another way to write it. So you do have to divide your y by x and try to get that. Rationalize that. Yes, yes, that's the thing. Okay. Question?
Yeah.
So we're
No. Okay. You take 1/2 over the square root of 3 over 2, and you get 1 over square root of 3 because the 2's cancel. And when you rationalize it, I want this one. When you rationalize it, 1 over the square root of 3 becomes square root of 3 over 3. When you multiply it by square root of 3 over 3. Square root of 3 over square root of 3. You get. So maybe I need to say that y x one half over 33 over 2. And I don't know if you can remember that the 2's cancel here, makes it easier. Or flip the second bracket and 2 and then you rational. So either way, you can write it here like that. But the 2's, if you have fraction over fraction, it's the same, it's always the same. But you can't get the idea of 1 half divided by 2. That's yeah, the 2 denominators have to be. We can't do 1 half. Well,
So wherever this is,
right. So it's 5 and 6. Right.
so when this falls inside,
It's still that way.
Yes. Well, you're going to be dividing either it could be here or here, but we have to be between here and here.
so it depends on what you're.
Yes.
We literally have to do this, like here.
Yes. Figure it out. When you cancel it, did you get a cancel? What's 2 pies?
Maybe be a radio small division, right? Okay, yeah, that should be right.
Right. Yeah, what's the answer?
I think your head hurts, man.
I'll tell them maybe I was saying that, sorry.
You're not canceling.
The operator had something?
Right. Cancel the 2.
No. We're getting passionate about that.
Oh, you got it. Yeah, that's it. So that means that this angle right over
Man, don't they have like
6
signatures?
You got, you found it on the circle. This angle is 5 of 6, this is where it's so the angle.
Everybody got their time.
You guys get this?
The only reason why I
Get it? You get it?
Yeah.
Yes.
That's true.
Everybody over here getting the workout crop. Like that. Positive 5 or 6. Okay. That's right. You get rid of that equal. Yeah. There we go.
I just did.
You would do cosine theta equals -1/2.
And then is it order?
So and those are the right restrictions. Correct. So then you need to look at 0 and
It's seriously only
okay.
Moderate tracking these guys.
I think that's correct.
Oh, these guys are, I did, I have to just change it by routine, not between minus pi and
Square root of 3 over 3.
minus pi over 2. Pi over 2, I had to go ahead and find that change by using the unit circle. That's the first thing. Theta equals this. Then do a worksheet inside out.
You get 1/2 times.
And then I forget theta
By where it's.
and then I do stuff up here.
That's interesting.
All right, you guys.
I got one.
All right.
If you want to change it this way, you walk.
You can. All right, I'll talk about it again here.
3.
You get this.
Yeah.
Okay, I'm going to talk about it. I'm going to talk about 3. The numbers started over again, didn't they? Okay. How did you do that? Okay, so where is X? Yes, that's your answer. Theta, this answer is theta is pi over 2 is pi over 6. Maybe you're making a mistake. Maybe you're at pi over 2, you have a half over second fraction gets you
So in order to get the fraction out, you take flip this one. So right now,
Yes.
you're working on this side, you got a right one.
Yeah, the table basics are negative 3 and then you can write it as so, what's it inside out?
And what she has up there is
Okay! Alright, so I think everybody got the first 3. This answer, theta, tangent theta equals the square root of 3 over 3. And theta has to be between minus pi over 2 and pi over 2. Alright, this is a brand new pen. And pi over 2. And this is a little trickier, but you look on the unit circle, and if you put 1/2 over the square root of 3, and then you can flip the second fraction. And then the 2's cancel, and you get 1 over the square root of 3, and then you rationalize that, and you get the square root of 3 over 3. So tangent of pi over 6 is square root of 3 over 3. And so it turns out if you have the same number in the denominator here, you don't have to go through the step of flipping the fraction. You can just cancel the denominators from a fraction over a fraction. But you can't cancel, what you can't cancel is this. If you have 1/2 divided by 2, that's really divided by 2 over 1. You can't cancel the 2's there. But if you have one, because this would actually equal 1/2 times 1/2 is a 4. But if you have 1/2 over the square root of 3 over 2, you can cancel the denominators, because when you flip it, they're going to cancel. You can save a step if you want, and then rationalize it. Okay? But don't try to save the step here and cancel these things. And that, I've seen people do that when I show them this trick. They'll cancel there. So, right, you have to over a fraction. It has to be a fraction over a fraction.
And then if the denominators match, they cancel. And that's always going to be the case on that unit circle. So you're going to be canceling those denominators in one step instead of 2 if you want. Okay, so we got that, and so theta equals, the answer is theta is pi over 6. And then the next one, we just write theta equals, then we write cosine theta equals -1/2. Remember, this is a number. What does this mean? The angle whose cosine is -1/2. And then, but cosine, you look up its restrictions, it's restricted between 0 and pi. So you look on the unit circle where x is -1/2. So the x is -1/2 at 2 pi over 3 between 0 and pi. So the answer is theta equals 2 pi over 3. Okay, how do you use your calculator? Well, if I want it measured in radians, change your mode to radians. And the calculator is just going to automatically do it for you, but it's giving you a decimal approximation. So if I tell you to find an exact answer, you can't use the calculator. Although, if you have, I would suggest trying to check your work with the calculator, or, but I will ask some of these to use your calculator. And it's definitely better to use your calculator than to use a blank. And it said 2 places, so this is -0.68. And I do have my mode in radians. Remember, this is a number. So with your mode in radians, you got an angle of -1.54. These are angles. The angle whose tangent is -30. Okay? Now we're going to talk about these. And before class, I drew a little picture. Okay. You guys got that? From the next one, a composite trig function. It's kind of got crazy here, but your book is really good. Page 620. Has the restrictions and all this stuff. The examples are here are excellent. It goes through the inverse properties. And I tried to show you this in class too, but why do we have to restrict the domain to -1, 1 when we have a composite function of inverse sine in the middle inside and sine on the outside. It's the sine of inverse sine of x will equal x, but you have to be in this interval. So I tried to draw a picture of that. So here's a picture of it. Here's the inside function. We've got x going into the inverse sine of x. Here's the picture of inverse sine. X has to be between -1 and 1. Otherwise, it doesn't work. Now, you want to try it on your calculator? Try to put in sine inverse of -1.01. Quit. Domain. Yeah. Okay. So this is the graph of it, and x goes between -1 and 1. So you can't, this is the inside function. X is going into the inside function first, the inverse sine. So you've got to use this restriction. All right, then you're getting an angle out from the inverse sine of x, and that angle, here's the y equals sine x function, has to be between -pi/2 and pi/2. Well, when you take the sine, your angle is always going to be between that for this case. So these are the restrictions here. We have to use these restrictions and these restrictions together, and this is the most restrictive. So we got to make sure. So this doesn't matter because it's more than those. So you have to have these restrictions. Anyway, okay, so how do you work these? And so you work from the inside out. You work from the inside out. We already did these. Okay. We're talking about the next group. You work from the inside out. So you look at tangent of 2pi/3. Now, remember the restricted domain of tangent of theta was that theta had to be between pi/2 and -pi/2 and pi, not less than pi/2. Those are your restrictions for tangent theta. Okay, is 2pi/3 between these? No, it's not. So we have to go ahead and evaluate tangent of 2pi/3. We're going to find that by saying tangent is sine over cosine. So this is an angle. We've got an angle here. We got sine over cosine, which is y/x, right? So we look at our unit circle at 2pi/3. Unit circle. And knowing and it helps if you can do some of this math in your head and look at 2pi/3. We're going to be doing, I'll go ahead and write it down. Square root of 3 over 2. Tangent of 2pi/3 equals square root of 3 over 2 divided by -1/2. Y/x, we cancel the 2's, we get negative square root of 3. Did you get it? Oh, you're just...
I'll put my diagonal.
Okay. So, and it helps if you can do some of that in your head to recognize, oh, it's got to be this one. Because the 2's are going to cancel, you put this over that, that's what you... But anyway, negative square root of 3. So we got So that equals negative square root of 3. Now we're going to plug that in for tangent of 2 pi over 3. We're substituting. So we've got tangent inverse of negative square root of 3. Theta equals. Now it's like the problems we did above. It's just like those problems. Now if this had been in the domain between minus pi over 2 and pi over 2, we would have just gotten the x out of it. So maybe I can, so then you're going to work this like you did that above. You're going to set, this means that tangent theta equals minus square root of 3, and you've got to be in the restricted area of minus pi over 2 domain and pi over 2. You look on the unit circle between these values of theta and find negative square root of 3. So it helps to be able to do this in your head a little bit, but here it is. If you put this over that, you're going to get negative square root of 3. So it is negative 2 pi negative pi over 3. This would be negative pi over 3, because this is 5 pi over 3 plus 1 pi over 3 would be 6 pi over 3. So this is, let me draw that, negative pi over 3. You've got a negative pi over 3, so theta is negative pi over 3. And that's your answer. That's an 80. Rating. Okay, so it added a layer of stuff. But I think you should read the book. Okay? Read this book, read the extra examples, because we don't have time to do this, every class period. I wish we did. I mean, I could have you look at the notes first, and we just skip the notes and just do examples. I don't know.
I would like that. I like working examples.
All right, well, let's do that. You guys look at the filled-in notes, see if you have any questions, and then we'll just do examples in class.
I feel like that helps me more. Yeah, because I like being able to actually work, because I can read theory all day long, but if I don't know how to work the theory, I can't do it.
Yeah, and this is important to do this. Okay, so
For the most part, I understand it.
is it starting to get?
I'm slow when it comes to math, but so like I come at least a little bit closer.
You're a little closer to understanding.
Yes.
Well, I now know how to do these. Before, I'm like, I don't know.
Okay.
Yeah, I'll give you that at least.
See if you can do this one, and then I'm going to do. I'll do one of these. So if you do this one, what's the restriction on the cosine domain?
0.
Theta for cosine has to be between 0 and pi. Is this angle between 0 and pi?
Yes.
So in that case, this just equals 2 pi over 3, and there's no work required.
There's.
Okay.
But even if you didn't do that, you can still work it out and get 2 pi over 3.
Okay, you could do the whole thing that I did up there. You could also do the whole thing I did up there and find the cosine of 2 pi over 3, and then set it equal, and then you're going to find it.
Because that's what I did.
That's what you did. Okay. That's not a bad exercise. So you figured out that it is just x. And this is what it says in the book. This is what it says in the book. were we doing cosine and cosine inverse? Or no, we're doing cosine inverse of a cosine. It says if we've got an x in here that's in this interval, it's just going to equal x. This is page 622 in your book. And we put these on our notes. We wrote these down, but you had no idea what it meant. So here it is. So, and the other thing that really blew my mind was that if you got inverse tangent on the inside and tangent on the outside, because inverse tangent has a domain of all real numbers, and I'll show you a picture, I drew it before class. And everything that comes out of there will work in tangent. You just get x for every real number x. So, for that one. So I drew a picture of that. If you're going into tangent inverse, here it is. The domain is all real numbers. Okay, x, the domain of x, is all real numbers. You're going to get out numbers between minus pi over 2 and pi over 2, not including those. What's the required domain for tangent? Minus pi over 2 to pi over 2. Well, that's all you're getting out. So for all real numbers x, if you take the tangent of inverse tangent of x, you're going to get x out for every real number. So it freaked me out. So here, so tangent of tangent inverse of x let's replace x with, and if you put any number in here, so they had, the book had 125 in here for x. 125. You get 125. You can put in tangent of tangent inverse of 2000. Doesn't matter. Whatever you put in here comes out. You can do that in your calculator. And you will get that. If you take the tangent of second tangent inverse of 2000. And no matter what you put in, you're going to get x out. They're inverses. They're undoing each other, and there's no restrictions on the domain for tangent inverse. And whatever comes out of tangent inverse, or y, is always in the domain of tangent. So that's why this works. And you saw it on the calculator, right? So these are all on our notes. So, but that's the only one where it's for all real numbers x. On this one, you have to be in this interval because tangent x is first, and it requires x to be between here and here. And then you get numbers out, all your numbers out work for tangent inverse because it's all real numbers. And so, but you have to use the restriction of going into tangent. You have to use the most restrictive restriction. These are composite functions. So if we drew, if we're going into tangent x first, we have a restriction of x has to be between, not equal signs, whoop, minus pi over 2 and pi over 2. You're getting things out, and you're going into inverse tangent. This allows minus infinity to infinity into inverse tangent. But we need to use this restriction, minus pi over 2 to pi over 2. And so that's why when we did the example with tangent of an inverse tangent, tangent inverse of a tangent, that's why it didn't end up being. So there we are, tangent inverse of a tangent, and this was not inside that domain. We had to evaluate this and then find that. Okay? All right, the last example, and I'm not worried about this time. I'm not worried about it. I'm extremely worried about the time, but I want you, it's more important for you to understand.
You know what will take a lot of stress off you? If you just decided to make that test to take home. Then we can just really focus on the learning.
Do after spring break.
We will think.
It gives us a whole other day of learning.
Yeah.
I'd go for it.
I'd go for it. I mean,
All right. So, how do we do these? In a sense, sketch to find the exact value of the expression. These are more like the worksheet that's due. So we start on the inside. This is the inside. So we're going to write theta equals inverse cosine of minus a third.
Couldn't you skip that? Couldn't you skip that step and just write cosine
Yes.
of theta equals negative 1/3?
Yes. Yeah, you could. As long as you have that on your paper, sure. You skip that one, okay. As long as you understand, this is a number in here, and we're looking for an angle on the inside, okay? And cosine is adjacent over hypotenuse. You have to have that memorized. Okay? Okay, so we're going to draw a right triangle. Now cosine has to though be between 0, the restrictions between 0 and pi. So we got to draw our triangle to make cosine negative 1/3. The hypotenuse is never negative, so we got to make x negative, and then that's the hypotenuse. So we're going to draw. This is going to be 3. We got to find b here. This is a right triangle. We drew it in quadrant 2 because that's where cosine is negative. And it's in that restricted domain. That's why it's not in quadrant 4. Now we're going to take the Pythagorean theorem and say minus 1 squared plus b squared equals 3 squared. So 1 plus b squared equals 9, and we subtract the 1. B squared equals 8, and then b equals the square root of 8. But you got to rewrite 8 as the square root of 4 times 2. So that's 2 square root of 2. So that's what b is. This is our theta. This is our reference triangle, theta prime. All we have to do is find now the tangent of theta using the triangle. Tangent of theta is it's opposite over adjacent. Opposite over adjacent, that's 2 square root of 2 over negative 1. So the answer is minus 2 square root of 2. That's the answer. And this is a number. This is an exact number, but it's a number because we're taking the tangent of an angle. The inside's an angle. We're taking the tangent of an angle. We're getting a number. So see if you can work the last one. So you're going to use these skills when we go to the next section. Okay? So you get confused between numbers and angles, so that's why I keep emphasizing that. So for the next one, the answer, I'm going to write the answer down, which would be worth no points without work. The answer is 2 times the square root of 13 over 13. See if you can get that. You may need more space than what I've given you. Okay?
Yeah, I'm going to write this on the back.
Yeah, I'll write it on another piece of paper. You need a blank piece of paper. Here's a blank. So you don't have to turn it over. Okay.
Do we just get the credit for being here?
This is a 100-point classroom grade.
Like rates?
No, you don't have to. I'll just use it then.
I got that.
Okay? Is this helpful? I think it was. Very helpful.
Practical applications.
Okay? So this is the last page of section 4.7. And unless you can do this, you're not going to do trick. Okay? Okay. Has your mind been blown yet? Did you find the, okay. So what quadrant are we going to be in? Yes, it's negative go down to quadrant 4. That's right. And then, negative 2, 3, right.
Wait, that's all right.
Come back there.
It was great. Okay. Well, maybe we'll have you look at the notes before class, right? Just for this stuff. And we get positive. Well, we have to be in quadrant 2 because the restrictions of tangent are minus pi over 2 to pi over 2. Well, no, it's because tangent has restrictions.
Because my brain is.
In order to be positive, you have to be
But yeah, I totally screwed up.
writing restrictions. You didn't write them on paper, so. Well, you are clear. Tangent. At first, I didn't write this. This has to be in quadrant 4. Yeah, 4. We're in 2, not 4. We can't minus pi over 2 pi over 2. Because we're doing domain is besides that, yeah. So you have to draw that picture there, and then that get a positive.
That's what you get.
So she's right except where you right. Okay. All right. Well, so
down to cosine.
okay, did everybody? So I got my work here for this one. I write that, then I write this. Tangent theta is minus 2/3, opposite over adjacent. I had to draw my triangle in quadrant 4 because that's between minus pi over 2, then pi over 2. And then I 2, then the 3 must be negative. Oh, did I do this wrong?
Yeah.
Yes.
That just depends.
It's opposite of, okay. Oh,
Yes. Yeah, I did it wrong too.
I did it wrong, never mind. Okay, opposite over adjacent, this is our angle. Opposite is minus 2, this is 3.
So that changes the answer to root of 3 over root of 3.
And then this is wrong.
It's root of 3 13 over 13.
It's this then cosine is 3, oh, it's 3.
So 3 13 over 13.
Yeah, right, square root of 13 over 13.
Yeah.
I got it.
Oh, so I got the wrong answer.
Generic French though.
I had my picture wrong, sorry guys. It's very, at 10 o'clock last night.
See, that's why I was mad. You gotta get it at 10 o'clock.
Oh, did you have questions?
Yeah, I don't understand. So how do you
Oh, wait, it's just a wide portion. Down on Y. Okay, tangent is opposite of adjacent. So, not this. So, opposite
Potassium's king.
from, oh, you always draw your angles with the, against the x-axis.
Okay. But I got those right.
So you have adjacent and then you found where we go. I think you could have
Once you get to there,
One of the girls in my class, she forgot.
oh, no, you're getting two sides.
So she answered it.
That's why it's square root of 13. You get R, it's square root of 13.
Well, not negative 3 over 13. I don't know how about that, but I got it.
the first day.
Okay. So your R is square root of 13 there, because you have two sides. Square root of 2 sides, 4 plus 9 is.
But I got that wrong.
And then you take the cosine, which is the adjacent over hypotenuse. And I got that one wrong, but it's 3 over square root of 13. Is 3 over square root of 13. Okay? And any questions on that one? Do you need help? All right. Should we? I'll just talk about this next section. You look at it, and I'll answer questions on it. It's not as hard, but we will be solving today. Let me see. And I may give you a take-home test.
Yeah.
But that would mean everybody, there's not a non-calculator.
Oh, darn.
I just have to trust you guys not to use your calculator.
We swear on our honor.
It's the honor system, man. I was about to say, you don't have much.
Oh, well.
Your honor.
If you don't show your work, you won't get the credit. Okay. 4-1, okay, so, where's the, section 4-8, not as bad, trying to find my empty note. Maybe, so we'll just do a little bit of this, maybe only the first example, but that's okay. So you're going to be doing this stuff when we solve triangles. And to solve a triangle means to find the missing length and you're going to find all the lengths of the triangle, the sides, the missing angles. I'm sorry. What? Solving the triangle means to find the missing angles and the missing sides, which are lengths. So there's a typo on the building notes. Ready? You got to find the missing angles and the missing sides. These are right triangles. These are right triangles in this section. So you have one angle that's 90 degrees. So you don't need to find that one. So if you've got an A, so we've got a picture here, and you'll have to do this on separate pages. And I'll do this first example, and then we'll quit. We got A, B. These are our angles with the capital letters, and we got across from the angles are the lengths of the sides with small letters. So little a is directly across from angle capital A, and that's given to us as 8.4. We don't know what B is, and we need to find C. Okay, and this is a right triangle. So, A here is given to us as 62.7 degrees. Oh, guess what? This section we're going to work in degrees again.
Oh, good.
Okay. Well, guess what? The angles of a triangle add up to 180 degrees, the inside angles of a triangle. So the angle A and B, angle A plus angle B has to equal 90 degrees exactly. So we can find angle B by subtracting, our A is 62.7 degrees plus B. So we're going to subtract from 90 degrees. B is 90 degrees minus 62.7 degrees, and that is 27.3 degrees. That's one of our missing angles. We got that one now. We don't need to find the 90-degree angle, guys. All right, now we need to find sides B and C. Well, it's kind of convenient. You know, this is 27, then 0.3 here. We're going to use the inverse functions to find those. The angle whose tangent is, or the angle whose cosine is. So we want to find B, and tangent of 27.3 is B over A. The tangent of 27.3 degrees is going to be the opposite side over the adjacent. It's best to end up with your unknown in the top of the fraction. It's easier that way. B over A, which is 8.4. Now, okay, on this one, all you have to do, you don't have to use the inverse tangent at all. You know, you're not missing any angles. All you're going to do is, we did a problem like this before. We're finding B, we multiply both sides by 8.4. Make sure your calculator is in degrees. And we can find angle B. So we have to turn on the calculator, go to mode, and change it back to degrees because we had it in radians. Second quit. Then we do 8.4, because you get the totally wrong answer if you leave it in radians, times tangent of 27.3. And so to 2 decimal places, B is 4.34. Now you got a choice on how to find side C You can use the Pythagorean theorem, this squared plus this squared equals that squared, or you could do I did a sine function, maybe in the filled-in note. You can either one. Maybe it's easier just to do. I did sine of 27. No, I did. Let's do another color. Sine of. I'm finding C now. Sine of 62.7 degrees equals A over C. Opposite over hypotenuse. A is 8.4. We can switch these around. You can cross multiply, or switch these around. C is going to be 8.4 divided by sine of 62.7 degrees. Then you divide that, 8.4 divided by sine of 62.7. And we get 9.45. And that's solving a right triangle. That's one example. We've got all the sides, we got all the angles. Okay? Now we will, so look over the rest of them. Look over the stuff. We'll talk about bearings next time. The next two examples are pretty much the same. So, look at my filled-in notes. We'll do bearings. And, okay, what's due next time? We're not gonna, where's Joby? I think I'm not gonna make you do that last.
4.8 worksheet.
Yeah, I'm not gonna make you do that one. So
4.7, 4.8 worksheet.
So I still want you to do this one. Try to do that one. Send me messages if you struggle with it. Some of you still struggling with graphing, so I gave some hints on that one.
All right.
Look at all those hints. Okay.
Oh, boy.
I'm graphing it. So you get the 5 key points. You divide your period by 4. And, okay? So you still have to do that, 3 pages. But we're not going to do the other one. So only one worksheet due. This, I'll just change the due date to Thursday. We'll see, it might be due Thursday. I might be Thursday. All right, see you next time.